Here we go. Welcome to MSUA Game Changers webcast, where we speak with satellite and mobile connectivity thought leaders about industry trends and share what you need to know about the future of mobile satellite communications. I am your host, Roger Lanto, and I'm excited to introduce Rob Lamontagne.
That's right.
Vice President, Strategic Partnerships at Katalyst Space. Katalyst Space is preparing to launch its Nexus robotic spacecraft to rescue NASA's Neil Gehrel's Swift Observatory before it deorbits. The mission will be the first of its kind and reflects Katalyst's ambition to expand satellite servicing to multi-orbit, multi-mission operations, which is all extremely exciting and very unexpected. I just learned about this very recently. But before we get into that, Rob, tell me about your professional journey and where and when satellite technology became part of your life.
Of course. So I grew up in New Hampshire, and my journey with satellites started at the University of New Hampshire. I was a mechanical engineering student, and while I was there back in before 2000, there were very few programs that were actually undergraduate satellite programs that were run by students. And so my university was one of just a couple at the time. It was called CatSat. We were building a satellite that was going to measure gamma ray bursts from the sun in a sun synchronous orbit. But ultimately, that satellite never launched. So that's unfortunate. But I got to be able to lay hands on some of that design work early on. Ultimately, after college, I joined the Air Force. Spent a long 25-year career in aviation mostly. And modernization of the Joint Force for the high-end fight. But as your listeners certainly know, satellites through satellite communications and precision navigation and timeline are absolutely critical for aviation. And so, as a long-range bomber pilot, we were absolutely reliant on precision timing so that we could have our keys synchronized up and get our secure communications. We are reliant on a navigation to a point, right? I mean, the missions that I flew, some of them could be done without GPS, but it was definitely a relief if you did have it. That would help your workload. And then, of course, the satellite communications played a huge role. Where I flew, long missions from, the central time zone to any parts in the world. Those could potentially be something like 44-hour sorties. And you obviously have a highly competent team in your cockpit where you're working to do important missions. But with the satellite communications and being able to build an adaptable communication suite on our platform, that allowed us reach back to our mission planning cells that would be able to continually refine the missions, provide us updates, make sure that we had absolutely the latest intelligence and understood everything that was going on with the situation on the ground as we were getting ready to go feet dry.
Very nice. So now describe Katalyst's journey to arrive at this important turning point.
Yeah, thanks. Well, let me just kind of start off by saying, Katalyst is an American technology company focused on dynamic space operations. We are a startup, and so we started in 2020. And the startup journey always has a couple of different pathways. And one of the things that Katalyst got onto relatively early was this idea that satellites should not be a throwaway economy. Everyone thinks of space as something you build, you launch, it stays on orbit for a while, it does its mission, and then it's just disposed of. Either it re-enters the atmosphere or it goes to a parking orbit, but at some point it just dies and becomes junk. Imagine if you were to buy a brand new car and it comes with a full tank of gas, and when it runs out of gas, you just leave it on the side of the highway and you go buy a new car. We don't think that that's the right way to go with Space 3.0, and so Katalyst is really moving to bring that forward. So one of the things that Katalyst was doing early was trying to find a way to add new capability to existing satellites on orbit. And so we came up with an approach to do it where you bring your own power, you bring your own data, you attach it to a satellite, and you can provide satellite operators with some sort of new capability that either was not available or they didn't realize was as important back when they were developing the satellite years ago. But what we realized was that you really have to own the robotic assembly and the robotic docking and an attachment point of that for it to be an economic case that closed. And we discovered that this robotic servicing was just an underserved, practically non-existent market. And so we are out there making this happen. And we believe that satellites should be able to be refuelable, repositioned, repurposed for different missions, upgraded even, and repaired. And that's where we're at.
By the way, in that realm, what's been demonstrated to date is capturing that so-called junk, as you describe it, and deorbiting it safely. I mean, that's what's been demonstrated so far, right?
Well, even that is questionable, right? So there are reports of certain actions being moved to a parking orbit, not exactly brought to a deorbit. And so there's been a number of experimental type activities, but it really hasn't been offered as a commercial service yet. And so that's where Katalyst coming along with our spacecraft we call the Link mission to go and save the NASA's Swift Observatory. This is the first time it's really an operational mission for a real world thing and not just either a government program or something that was done as an experiment or a gimmick.
Seems like a pretty huge deal to me, but we don't do anything on our own, right? So what are some of the partnerships that were necessary to deliver this project?
Yeah. So I think the first thing is that we've just had this amazing, great partnership with NASA. The folks at Goddard Space Flight Center have been along the ride with us from the beginning and sitting in with us on our internal design reviews and kind of thinking through how can we mitigate some of this risk, which elements of risk are appropriate to accept as prudent risk. And they've just been really a good helpful in trying to figure out how do we navigate the different bureaucratic things. I should say that this mission is historic for lots of reasons, but one of them is because it's faster than probably any other mission in certainly recent memory.
Yeah, I think you mentioned something about that when we were speaking yesterday. Why don't you talk a little bit about that?
Of course. So the Swift Observatory is one of the deep space telescopes that measures, space activity out even outside our galaxy and things like that. It detects gamma rays and then points its exquisite sensors in that direction because they're fleeting in time. And so its science payload's in really good condition. And the only problem with Swift is that it's been on orbit for 20 years or so, and it's just been slowly losing altitude over those course of time. And as you can imagine, that altitude is sort of an exponential decay situation. So the closer it gets, the more drag it experiences, and the quicker it starts to come in. And so as NASA was watching the predictions of its reentry, they sort of thought they had several years out to go. But back in 2024, there was a large solar activity from our sun kind of doing this mass ejections. And when that happens, our atmosphere expands slightly. And so that exponential decay started to affect Swift. And so they found themselves about a year ago, maybe a year and a half ago, realizing, oh my gosh, Swift is going to come in by the end of 2026 if we don't do anything about it. And so last summer, they put 3 companies on contract to do a quick study and see what's the feasible thing. And so they chose Katalyst as having the technical solution that was doable and an approach that was plausible to get there. And so we were awarded this contract in September of 2025, and we need to launch this month, right? So we're now just double digits away from launch. Back in September, 9 months ago, this was just a napkin sketch. And so the fact that we have built an entire robotic spacecraft that's doing a mission has never been done before in this 9 months time is just sort of a miracle of that. Part of that, you asked about partnerships. I mean, we did have to find a launch provider that could reach the orbit we need to get to on the right timeline and do it in the right way. And so we actually chose a Pegasus, which a lot of folks may or may not know is an aero-launched rocket. And so that allows us, so that's why we're going to Kwajalein atolls, because the Swift is in this relatively rare orbit called 20.6 degree inclination. And so in order to fly to that correct inclination at the right time, you need to essentially have a good track from west to east. And that's why we're going out there to the West Pacific.
Wow. Okay. And that is, again, the date and time is?
Yeah, so it's going to launch on 30 June, and I forget the Zulu time, but that it works out to about 6:30 a.m. Eastern time.
Now, it sounds like there's a whole bunch of challenges to making all of this happen in the fashion that you have. Does any one or two things stand out in particular?
Well, of course, it's a very technically challenging mission. Again, never been done before. We're going to be capturing this large multi-ton satellite with our little refrigerator-sized tugboat. We're going to be doing it at a relatively low altitude because it's about to re-enter. So we're going to be feeling the effects of drag while doing so. And so, you know, our folks are working through all the technical issues. But the bigger issue is just nobody thought this was possible from a perspective of supply chains and design, and folks haven't really thought of America as being this industrial giant for a long time. So I think that this is really proving that America's back, and we've been able to work through all these technical problems with supply chain issues and things like that. A lot of times that meant we need to bring a lot of the architecture in-house because the parts and components, things like that you would normally order out of a catalog just couldn't meet the timelines we needed to. And so we brought a lot of that in-house, and that was a major challenge we had to overcome.
Yeah, I come out of the automotive industry, and I was just at an event last week in Europe where everyone was talking about China speed. Well, now we've got America speed. So now, once you've demonstrated this capability, what else is possible?
Well, like I sort of let out that vision again, we are bringing about this idea of Space 3.0, the dynamic space, where we don't have to just think about things as you know, the throwaway model. You know, for so long, people have been thinking about, okay, we're going to put a satellite up, costs a lot of money, and then I'm in this false decision about whether I need to spend another $500 million to replace it, or if I just do nothing and let it die. We're going to be able to do things like life extension for our commercial satellite operators. We're going to be able to do things like boost for high value assets that are in low Earth orbit. You know, we'll be able to do things like deorbit defunct satellites to make the environment safer for all those other satellites. Repairs, upgrades, a large form factor assembly. And so, you know, there's a lot of talk in the space industry about whether the physics close or the economics close of orbital data centers or power beaming and things like that with large arrays, and all that stuff is interesting. But at the end of the day, it doesn't matter if you don't have robotic assembly, you know, and you need to be able to resupply. Like, when was the last time you wanted your computer to just never be upgradable? So there's going to be a lot of that, we think, that we're going to be able to enable and make everything else kind of be adjacently possible, if you will.
What's next in the near term?
Yeah, so as soon as we're done with this mission, we're starting on our next mission. So the spacecraft we're launching in the next couple of days is called Link. The little bit bigger versions meant for the geospace environment is called Nexus, and we're launching that next summer. We already have a launch, you know, booked and paid for and everything else, and so that's going to go up, and it's got at least 3 different missions that we're going to do for multiple different partners. And we're really kind of proving out with that one that our business case of dual use and multi-purpose is really meaningful, and it provides synergies that really can't be accomplished in other ways. And then, of course, I can't speak about other contracts, but as you might imagine, we're getting quite a bit of traction as success begets success. And so, you know, we probably are going to, you know, accelerate our plans to scale. You know, we had talked about doing the Link mission and then doing the Nexus 1 mission, and then maybe a fleet of Nexuses in the year after. And now we're looking at trying to pull a lot of that left as much as possible.
Wow. And at the event we were at last night, there was a lot of talk about regulatory issues and things. So how has regulatory support been as an important part of this market development?
Yeah, of course, it's something you need to deal with in all parts of the space industry. And you know, some of the issues I can probably speak to is again, the partnership with NASA has been great. You know, in order to do a mission from scratch in 9 months, you probably need to get, you know, the right waivers to certain things that are just not normally considered possible, and you have to think through that and make sure that you're still meeting the intent of the rule, even if you're getting a waiver to the letter of the law, if that makes sense. And so that's been pretty interesting. And, you know, knock on some wood, we've been able to get all the right permissions. and been able to do this thing fast. And I think that the fact that we're saving this, the Swift Observatory, the $500 million national treasure, has been a nice impetus to help us work through the regulatory speed that's needed, if you will.
And from a funding standpoint, this is entirely taxpayer dollars. Is that what we're talking about?
Well, that's an interesting question. So clearly we're a startup and we're doing the right venture rounds and things like that. We just closed a venture round that's going to help us finish our plans and development for the Nexus 1 mission. Nexus 1 is primarily internally funded, but then we're offering up those missions I talked about on orbit as a service. And so then the taxpayer gets a huge discount on that because they're not paying for the development, the design, the qualification of the space vehicle itself. They're just paying for us to go install the upgrade or deliver the payload or go and do the servicing itself. So that's really interesting. Now, of course, the NASA mission was funded by NASA through a small business effort. In terms of space, everything's relative, but it was very low cost for them. And again, a huge return on investment for the taxpayer, and the fact that our little $30 million contract to rescue this bird is saving a $500 million asset.
Yes, the beauty of repeatability and scalability. So where can people find out more about Katalyst Space?
Well, our website, katalystspace.com, Katalyst is spelled with a K, and LinkedIn is where we usually do our posting, that sort of thing.
Okay. Well, that's terrific, Rob. Thank you for making the time. I want to thank the Mobile Satellite Users Association for hosting these sessions. You can learn more about the MSUA at msua.org. You can learn how to get our weekly newsletter that gives you updates on everything that's happening in the industry and shares information about upcoming events. And you can also find out how to become a member. We look forward to seeing you next time on MSUA's Game Changers webcast. Thanks a lot, Rob.
Thanks, Roger. Thanks for having me.
Bye-bye.